Hey, welcome back to another Astro class. My name is Keith Wasilewski. I'm going to be your host for the next half hour or so, and I'm not going to waste any time. We're going to get right into it. I want to share this model of the solar system. We're going to talk about a number of things today, but the main theme is going to be about a term that you may have seen on Slooh, and that is called Syzygy. Before we do, I want to look at the solar system model. And as you can see, we have the sun with the planets in orbit around it. Now, we can think of these orbits as a type of plane. And the plane between the Earth and the sun is something that we call the ecliptic plane. All the other planets are in orbit around this general central portion of our ecliptic plane, but they're at a slightly different angle. They're tilted a little bit from it. Each planet tilted to a degree, some more so than others. And as we see this, you can see the planets all more or less around the belly of the sun. That's because the sun is very large. It has a enormous gravitational pull, and everything tends to gravitate around the center of the sun. So when we look at this, I think I'm going to move some planets around. We can infer a couple of things. As the Earth moves around the sun, the relationship to the other planets is going to change. So what a syzygy is, by definition, which I have written down, is roughly a straight line configuration of three or more celestial bodies like the Earth, Moon, Sun, or three planets in a gravitational system like our solar system. So the classic syzygy is this relationship between the Earth, Moon, and Sun. Now, I'm going to go back here and change my my Zoom controls are going to interfere with my solar system controls. Oh no. All right. Well, the classic example is with the Earth and the Moon. At the time of new moon, we have this alignment of the Earth, the Moon, and the Sun. So that's an example of syzygy, this lineup of three or more objects. During the new moon, that's when we have an eclipse. That's also a type of syzygy. When the moon is in perfect alignment with the ecliptic plane, it will appear to block out the face of the sun, and that's when we have a total lunar eclipse. On the flip side, if the moon is in this type of arrangement, where we have the moon, the Earth, and the sun, we have the opportunity for another type of syzygy, which is a lunar eclipse. That's when the moon passes into the shadow that's cast by the Earth. So an eclipse is a classic example of this type of arrangement, but there are others. We're going to look at some new moon arrangements a little bit later in the class, but I just want you to get an idea of this lineup. We have other things that can happen. We have types of syzygies that we call occultations. That's when usually a planet will pass in front of a background star. So as you can see, the celestial sphere in the background, we have the constellations, and each of the constellations of the zodiac, what we call the zodiacal constellations, will also appear along this line of the ecliptic as the sun makes its way through the celestial sphere. It's not really the sun that's moving, it's the Earth that's moving in relationship with the sun, but it looks like the sun moves through these background constellations. Each of the planets will do it, and the moon, of course, does it once a month. And it's something to look forward to on Slooh, and we do follow these movements. So, like I said, we have the eclipse, we have the occultation, when a planet will pass in front of a background star. We have something called a transit, which is when usually the inferior planets like Mercury or Venus will pass in front of the sun. These are actually fairly rare events for us to see on Earth. But we do have other examples of transits, and I'm going to do a new share, which is not going to cooperate for me. Here we go. Which is this. Shadow transits. This happens on the planet Jupiter all the time, where we see Jupiter's moons in orbit around the planet. And if we catch it at the right time, we will see the moon casting a shadow upon the planet itself. And we'll look at these at some point in the future. The interesting thing is the location of the shadow actually determines where we are in relationship to the planet. And I know from experience that we are before opposition in this instance. And since we're talking about opposition, let's take a look at what opposition looks like on our grid, on our model. Sure, okay, it's not sharing, sorry. There we go. So we looked at some of the relationships. We looked at the eclipse. We talked about occultations. We talked about transits. Opposition is a type of positioning that happens with the exterior planets. So this is a Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. We'll throw Pluto in there too. And any of the minor planets can also be at opposition. Opposition is this type of arrangement where it goes Sun, Earth, planet. So this is an example of opposition if you ever hear that term. Sun, Earth, Jupiter. We can do it with Saturn over here. This solar system model is not completely according to scale. For an object this size, the size of a pea, we would need to have a football field, with Uranus being the midway point, if you can believe it. That's how big our solar system is. If the sun were the size of a pea, we would need 100 yards to get to Pluto. All right, anyway, so this is another example of opposition where we have the sun, we have the earth, we have Saturn. Why are these oppositions important? Because that's where we get to see planetary detail. Mars, for example, right now, which has a 2-year and 2-month orbit, more or less, around the sun. We are moving away from Mars. We're losing all that Martian detail. But on the other hand, let's go to now. So look at where we are in relationship to Jupiter. We are approaching opposition. We were at a point where Jupiter was behind the sun, not visible. We are moving towards Jupiter. So we're not quite at opposition yet, which is why we saw the shadow in that image cast to the right. Saturn, if you notice, in this path is actually going to be first. We're going to reach opposition with Saturn first. I think it's sometime in August. I think I don't know, 29th or so. And that will be our first opposition star party. So it's right at the end of Space Camp. That's going to be a special treat if you get involved with Space Camp for those who take part now. And I certainly hope you do. So again, opposition is important because this is where we get to see, one, all the beautiful planetary detail, the belts and zones on Jupiter, the rings on Saturn, and some of the banding on Saturn. It's also where we get to see Saturn's moons. Titan, certainly the largest moon, and certainly, Jupiter looks much better. And maybe we'll go back to that Jupiter image. Uranus, we get to see, I think we can see 6 or 7 of its moons when we come into opposition with it. Neptune is always kind of just a small dot. Same thing with Uranus, but we do get to see Uranian moons. Pluto is just a dot, so opposition doesn't help us very much when we look at Pluto or some of the other objects beyond Neptune. So there is one other type of syzygy alignment that I want to talk about, and that is a conjunction. Now, we have different types of conjunctions, and you may have heard this word before. It's thrown around a lot. And what a conjunction actually is, when we go in to look at this, it has a very specific definition. So it's not always what is referred to as a conjunction. And we're going to look at that, but I want to look at this type of arrangement first. Oh, we're almost in it here with the interior planets. Now, we looked at the outer planets, Mars, Jupiter, Saturn, Uranus, Neptune. They can never be at conjunction. They can only be at opposition because they can never pass between the Earth and the Sun. And that is the first type of conjunction. So I have Venus here, kind of grabbed a hold of it. Oh, it's going to give me grief. Oh, I have to go backwards. All right. So you reach an arrangement where we have the Earth and Venus, and Mercury will do this too, between the Earth and the Sun. That's what's known as an inferior conjunction. Not because the planets are small in size or anything like that. It simply means that they are between the Earth and the Sun. Mercury will do the same thing. Oh, I guess we might as well do it. Mercury, my favorite planet. So we have inferior conjunction here. But we know that an arrangement will also exist where the planet will appear at the opposite end of the Sun. That's a superior conjunction. Okay, so there is a type of syzygy when we talk about inferior and superior conjunctions. So hopefully you can see that. That's not the type of conjunction that we are here to talk about today. And we've been at this for about 15 minutes or so. So I think this is a good time to take a Slooh break. Oh, maybe I'll talk about this first. When we look at the planets, and this is a good model, then we'll take our Slooh break. They move around the Sun at different speeds. And I'm going to move up the speed of the orbit a little bit. So the further a planet is away from the Sun, the longer it takes it to go around it. And the flip side of that, the converse, is the closer it is to the Sun, the faster it orbits. So Mercury, for example, has an orbit of 88 days. Venus is further away, but not as far as the Earth is. It has an orbit of, I think, 284 days. Mars, as I said, takes 2 years and 2 months, I think. Jupiter moves around quite slowly, 15 years. Saturn, I think, is 56 years. So there is a Slooh quest that talks about planetary motion. And now we're going to take our Slooh break. I want to go in and take a look at the Footsteps of Kepler quest. I think this is the right one. I've got it. All right. I'm getting a better hand on my screen sharing. So to find this quest, to learn about planetary motion, to find out about this idea of where a planet is and how it takes longer for it to move around the Sun, depending on where it is and its elliptical orbit and everything planetary, we go to our Slooh quest. So I already completed this quest. And if you scroll down, you'll be scrolling down probably under Browse Quests, but I'm going to do it here in the Footsteps of Kepler Planetary Motion. That is the quest. I'm going to take a look at it. So if you haven't done this quest yet, this was one of Dr. John Bovaire's earlier quests. It's fantastic. I took it right when it came out. It was a lot of fun. There are some technical terms. There are some equations. But when it comes time to answering the questions, he takes it easy on you. They're not very difficult, but the concepts are pretty intense. But the quest as a whole is within everybody's capability. I'm confident that everyone listening to this class today will be able to successfully complete this quest. Footsteps of Kepler, planetary motion. I don't know. Let's take a look at some of the steps. Capture the solar system, so you have to take some pictures. This are the pictures I used. Next step. This is where we start using some terminology. There's some great old images to look at. Okay, here he's talking about the orbit of Venus. So again, it's a lot of fun. I definitely encourage you to work on this quest and complete it and get your badge and your poster at the end. So that's Slooh break number 1. So let's go back and talk about this idea of conjunction. We talked about what a conjunction is. And I want to take a look at what are commonly referred to as conjunctions. We'll do this if this is going to work. Okay. I didn't share this earlier. We talked about occultations, but I'm going to show a picture, a quick picture. And this is what happens during an occultation. The moon is a classic occultation main player because it's just so big. This is an occultation of Mars that was taken by one of our Slooh members, Gretchen. And if I'm not mistaken, this was after the moon had passed over Mars. This was what we would call the egress, when the moon is leaving Mars. So that's one picture. This is another instance of conjunction. So remember, when we talk about conjunction, I said that there is a specific definition of it. And that is when we have two celestial objects that actually share the same right ascension. That is a whole other quest. I think it's called Plotting the Sky, where you can learn about right ascension and declination and how the latitude and longitude of the Earth can be transposed into the night sky, and we can divide it up and we can plot the location of fixed objects by coordinates. We can also plot the coordinates of moving objects, and that's what happens during a true conjunction. This is at the new moon, and even though we're not having an eclipse, the right ascension of the moon and the sun at this particular instance are the same. If you don't believe me, I have it up here in Stellarium. Right ascension is this number, 3 hours, 43 minutes, and 30 seconds. And these are the coordinates of the sun, 3 hours, 43 minutes, and 24.37 seconds. Why is there a difference? It's just because when I took the picture, I had to go back and forth between them and snap a screenshot. So this is one of those things you very seldom see me ever do, and that's use the this type of grid pattern on Stellarium. Usually I use the Alt-As just because it's easier to figure out the distance of objects. But we do have this conjunction that is a conjunction in the strictest sense of the word, where the two objects share the same right ascension. Now, I have the atmosphere turned off, but it's interesting to note here too that this is a daytime event. But we also have something else going on. We have the Pleiades, and the moon is in relationship with the Pleiades. It's not visible because it's during the daytime, but it is still there. And we're going to come back and look at this type of relationship. This is what most people talk about when they use the word conjunction. They'll say, oh, there's going to be a conjunction between Venus and Jupiter. I don't have the right ascension here, but they're obviously not lined up. This is actually what we would call an appulse. So an appulse is another type of syzygy, but it has a slightly different connotation in the sense that it's a more general term that describes the proximity of two celestial objects. The moment of syzygy during a passing, so for example, Venus won't pass Jupiter again until I think 2025. It's the closest approach in this particular passing of the two objects. That would be the moment of a pulse. Here it is again. I don't know where this was in relation, but you could see I was playing around with the days. So not as close, right? 3-2. I'd say the moment of pulse is probably here at 228. But that's what we're looking for. This is not really a conjunction. The conjunction is that sharing of the right ascension. And I don't have those grid lines up in this screenshot, but it doesn't look like it's that to me. This is really an appulse. This is the drawing together closely of two objects in the night sky. Now let's look at some more. I have some more of these. Again, I just played around with this Venus-Jupiter thing because this was fairly recent. Okay, this is when this is going to happen again. So 8/11/2025 is the next time Venus and Jupiter will be in this type of arrangement. This came up in one of our Tuesday night classes. Why doesn't this happen every year? Well, Venus is an interior planet, right? It's between the sun and the Earth, and the Earth has to be positioned correctly in order for it and Venus and Jupiter to be in, in the same lineup like it is here. That doesn't happen now with Mars, Jupiter, Saturn, Uranus, Neptune. That happens every year. Every year, the moon. Well, every year the Earth will come into opposition with them. And every month, the moon will pass through this path of the ecliptic, which we're going to look at some point. But not with Venus. It's a little different when you get into the interior planets. Very wonderful, beautiful sight to see with the naked eye. This is an image I got somewhere. I think somebody posted this to one of the Slooh groups. We can see very clearly this close alignment between these two planets, Venus and Jupiter. So when you hear about these things, these are definitely events that you want to go out and take a look at. These are things that you want to see. Okay, I didn't want to share that one yet, so we're going to go back to this. I think this is a time to take another Slooh break. Let me go back to my Slooh. I've got to pull this up. And I think this is the one. Okay, it's not the one, but we can get there from here. So how do I find out about these events? For those of us who follow such things, we know, okay, we're going to look at a final example of one of these at the very end. We know about them. But one of the places that you can find out about them on Slooh is right here in this workspace. Syzygy Central. That's how you say that word if you haven't heard it pronounced before. It's actually a Greek word in origin, Syzygia, but in astronomy we call it Syzygy. So you just click on that. See how I did that? You look for it in workspaces. Oh no, it's a doing it. Okay. Go down to workspaces. We click on it, and it takes us to the page. Paul is involved with this. Stephen Amon is very involved with Syzygy. He doesn't just post in this group, he also posts on Discord. And as we look here, I did look at this earlier. Joe the Asteroid Gal is looking at asteroids. There's a little mock-up here of an occultation of a star by Pallas, which is a small planetary type asteroid. You can see he did a blink comparison, and there's a map. Anyway, we'll go back. It's a great site. So this is one place that you can check Syzygy Central on Slooh, or go to Discord, or use one of the many online sites that keep track of these things. And definitely when there are planets involved, definitely go out and take a look at these. Not always able to capture them on Slooh because we need to have a narrow enough field of view in order to be able to see it. And sometimes they don't fit into the field of view of a Slooh telescope, but that doesn't mean you can't capture it on Slooh. You capture each object individually if they don't fit, and you simply stitch them together in a type of mosaic. So we're just about done. I covered what I wanted to go over, with the exception of one thing, and that is our special event that's coming up. I'm using this as an example because it is about to happen, but these types of events happen all the time. Let's look at the moon. So the moon, as I mentioned, follows this path of the ecliptic. I made it nice and big and red here. I don't have my clock turned up. So the moon will make its way through the entire celestial zodiac along this path, roughly, of the ecliptic. So you notice right now the moon is not on the ecliptic itself. It means it's outside of the plane. The moon is a tilt of about 5 degrees from the plane of the Earth and the Sun. And let me center it, and we'll watch it move. So right now it's in Cancer. It's going to make its way. Oh, I forgot. Let me turn off my lines. I always get complaints about that. It's going to make its way through Cancer. Oh, I want to go by day. I don't want to go by hour. It'll go through Leo, Virgo, Libra, Scorpius, Sagittarius, Capricornus, Aquarius. These are all constellations of the zodiac. We call it the zodiacal constellations, which are the parts of the sky that the moon and the sun and the earth and the planets all pass through. New moon, and then we're back to where we were. So the moon does that, like I said, every month. When the moon does that, there are objects that lie along the path, not just the planets. So let's go back here. We can go back a few hours. So this is a type of a pulse here, right? The moon and Venus. You will have the moon and Mars. I did a whole series of photographs with the moon and Mars. And the moon will do this as it passes every single planet along the path of the ecliptic. And we can see it if it's visible. If the planet's behind the sun, we're not going to see it. So let me go back to this, where we are today, regular time. So this is something that we have been looking forward to. This is an example of, I hesitate to call this an pulse. I think of it more as a type of transit. And what we're looking for is Mars approaching this object here. So it's not really an pulse because Mars is actually going to be right in the middle of M44, the very famous beehive cluster. It's an open cluster in Cancer. I always say it's pretty much the defining object in Cancer. The stars in Cancer are not very bright, they're very dim. And it's really the beehive, when you find it through binoculars or on Slooh or whatever, that you know that you're in Cancer. So this is what we're looking forward to on 6/2. I think of it more as a transit than an pulse, because a transit, again, by definition, is when a smaller object passes in front of an object that is much larger than it is. So, you know, the sun is enormous. Mercury passes in front, that's a transit. Venus passes in front, that's a transit. Jupiter is huge. When one of its moons passes in front of it, that is a transit, casts a shadow. If it's before or after opposition, and depending where we are in relation to it, that will determine which direction the shadow is cast. So this is kind of like the way I view this. The beehive cluster is enormous. Mars, by comparison, is not very big compared to it. So is it in a pulse? Well, there isn't really a degree of separation at all, is there, between it, because it's passing right through it. So we can kind of think of this event however we like. But it's a great event. We're looking forward to this. That's not the only thing that Mars is going to pass through. A couple months ago, it passed through the Lagoon Nebula, and it will come into contact with everything, again, that is on this path, or in the path of the ecliptic line, the plane that we talked about. Here, Regulus in Leo. So here's a Slooh photo op. I don't know if this is in the field of view, but you get the idea. Hey, we have a type of Syzygy here, don't we? Pallas with Regulus, and let's go back and get Mars kind of here. Hey, look at that. It's kind of exciting, isn't it? Got a star and the planet Mars and this minor planet, Pallas. Oh, sorry, it's over here. All right, you get the idea. So that's something to look forward to as we watch the motion of the planets. Like I said, since all planets move along this path, everything in its path at some point will have a planet going through it. So the deal with the beehive coming up is just one of the many areas and objects that Mars is going to encounter on its journey. All the planets, as I said, are going to do this. It may take a little bit longer. Mars, because of its short orbit, its orbital period, is more of a player with these objects because we know that it's happening every 2 years or so. Jupiter, I don't know, do you want to wait 15 years for that? Saturn, 50 years. For Uranus, some people will never see Uranus in certain parts of the sky. I think its orbital period is 86 years. So good luck on waiting for that, right? Anyway, that is my little class today and our little presentation on brief discussion of syzygy and eclipses and occultations and pulses and conjunctions. And of course, like I said, this special event will be available on Slooh, but it's not the only time that we're going to see these types of events. Syzygies all over the place. Again, if you look online, certainly in Syzygy Central, if you find that a little difficult to navigate, we are always talking about this type of information on Discord. If you aren't on Discord yet, please, I encourage you to join us over on Discord. We have so much fun, and it is so incredibly informative. And as I mentioned, we talk about this type of stuff all the time. I can't thank you enough for coming to be with us here today. If you have any questions, again, I'm on Discord. You can reach out to me and drop me a line, send me a private message. You can make a comment in Pixis chat. That's usually where most of us spend our time, and I'll be happy to get back to you. Once again, my name is Keith Wasilewski. Thank you for spending the last half hour or so with us here on the Astro class with syzygies and occultations and pulses and all these beautiful alignments of planets in our solar system. Thanks again. Have a great day.